All right, so we're going to look at using nested loops to set up and print, various triangular numeric outputs. So the first problem will say, use nested loops to produce the following output: a single one, then 2 ones, then 3 ones, 4 ones, 5 ones, 6 ones. There's several other problems down here that are going to sort of change the output slightly each time we go along. So I'm going to start on paper, and again, I would encourage you, when I'm in the notebook here, you write this problem down on paper, and we'll go through the pseudocode together. So we want to use nested loops. So the first loop will be the rows. So, for the rows, and the rows are going to start, well, with the first row. So from 1, and go up to, and we just count 1, 2, 3, 4, 5, and 6, from 1 to 6. And then the number of columns is going to change. So for the columns, I'll just put column. Well, again, the column is going to start at 1. But now the number of columns changes. So in the first row, so let's look at a little table here, row and column. In the first row, we have 1 column. In the second row, we have 2 columns. Third row, 3, 4, 5, 6. So we can see right away that the number of columns is equal to the number of rows. And generally, this type of problem, this type of nested loop, if we can establish a linear relationship between rows and columns. So in a sense, that linear relationship has the form, going back to my math stuff, y equals mx plus b, where y is the column and x is the row. And so the slope here, the change in y over the change in x, in this case, it's just y equals x, but I'm doing this to set up future problems. So the slope is the change in y over the change in x. And in this case, they're both 1. So 1 over 1, slope is 1. And the b is the y-intercept. And it would actually be what happens if I go back up 1 spot here. If I go back up 1 spot, if the row were 0, then the columns would also be 0. So we'd have a 0 and a 0. So b would equal 0. So the relationship here is that the column goes up to a top value of 1 times the row plus the 0, or just 1 times the row. I'm going to put the plus 0 because I don't really need either the 1 times or the plus 0. But in other words, the column starts at 1 and goes up to this equation, whatever it is. In this case, the equation is just the number of rows that you have. And then inside here, what are we going to print? Well, we're going to just print 1. Because on each row and each column, we're printing the same thing. We're printing 1. And then that's just a print statement. That's not going to get us to the next line from here down to there. So outside of that loop, we're going to need a print line statement. I know on this problem, I probably didn't need to do all of this work over here, but I'm trying to establish how do we generate these linear relationships between one of the variables, the row, and the other variable, the column. We're going to need that for our first project and for several things in between. Okay, so notice once I have the pseudocode, the problem is done. I've done all the work. So when I jump over to Eclipse, you could actually go to Eclipse and code this on your own right now, pause the video, see if it works. And then maybe on the next problem, you write the pseudocode yourself and then match it with what I'm going to do. That would be a way to sort of test yourself. Am I understanding the concepts as we go? Okay, so I'm going to jump over to Eclipse. That's not it. We are in chapter 2. Maybe make myself a little smaller. I'll just point out how cool the sky looks behind me over here. Isn't that a great color? Sorry. I digress. Okay, you can't do that in a regular class, only in the online. So I'm in this default package. Again, if you're on a Mac, you're going to be using a named package. Give it any name you want. P2 is probably fine. Okay, so we're in a new class. Again, I'm in the default package. I'm going to call this, what did I call this guy? Triangular numeric output. So we'll call it triangular outputs. Numeric, let's call it the whole thing. Numeric outputs. Because this is a triangle of ones, if you look at it that way. Public static void main. What that does is it sets up the template with main, the main function already set up. And I didn't talk about this, but the keyword public is saying, okay, everyone can access this. Everyone, it's other bits of code. So we're not doing that yet. So we're just naming it public. Static for the main, we're just going to have it in here. We'll get into why we have it actually later. Void means that this function doesn't return anything. It has no type, no variable type. Main is the name of the function. This is just needed for main string with the 2 brackets and the arguments. We don't need that content for any other functions that we're going to do, except main. So we just auto-generate it. But it's good to sort of learn that line of code. Okay, we'll come up here and make our comments. I thought I would do a generic comment, so it'd be your name, today's date, your sites, 142. Obviously, you're not going to type the words your name. You're going to type in whatever your name is, and you're going to put in a date, probably today's. And then this is this program will use nested loops, because that's really what we're doing here, to print various triangular numeric outputs. Are those comments necessary? No, but when you hand stuff in, I definitely want these 3 lines of commenting, and I want a comment that tells me what the program is doing. So for me, they are necessary. I want that stuff so that I can know whose program am I grading, but also, do you understand what your program is doing? That's what's highlighted right now. It's the analyze phase, in some sense, of the coding. If you don't understand what it's doing, you can't explain it, probably as you don't understand. So I'm tabbing in, so I maintain my tab, starting my loop. For integer row, we're starting at 1. Again, I'm using good spacing here between my different components. I'm going up to and including, so let's then we go to 6. And I'm increasing the row by 1. Open brace, return, it sets up my loop. Another loop. Oh, I'm not crazy about that space. I don't really want that space. You can have it, but it's usually easier not to. For integer column, so you could just say COL, but you know, to make things clear for us, it's easier just to write the word column out. So notice, again, back to our pseudocode, the columns are not staying constant. First we have 1 column, then we have 2 columns, then we have 3 columns. Columns are changing, and they're changing as a function of the row. And so ideally, those are linear functions. That looks so strange. Sorry. Those are linear functions. I noticed that sometimes when I'm in the on the notebook here, it's jogging up my video. It must be something to do with Zoom. I'm not entirely sure. I've never had this issue before. But anyways, column is a function of row. And ideally, these are linear functions, so we can set them up using the equation y equals mx plus v, and that'll help us going forward. In this case, it's very basic because the upper value is just y equals x, or column is less than or equal to row. And then the column will increase by 1. And then within this loop, we're printing the 1. So it's a print statement, not a print line statement. System.out.print. Notice I can also just, pull it. Well, I could pull it up here from this list of things, but I'm not gonna. I'm just gonna type it in. And we're gonna print the character. I guess I could do either way. I could print 1 as a number, or I could print 1 in quotes. I feel like 1 in quotes is safer. Okay, and then back at our pseudocode, I need that extra print line. That'll be something that people tend to forget on this type of problem, and it's outside this first loop, but inside the outer loop. Outside the inside loop, it's inside the outside loop. That's confusing to say. I'm going to type with my shortcut SYSO and then control space, and I just have an empty print line statement. And this program should be ready to go. And there's my series of 1s. Perfect. And maybe I'll put some comments in here about this nested loop. Nested loop to print output of, to print triangle of 1s. And this is number 1. So that it's relating back to number 1 over here. Okay, so this would be a great time for you to pause and try the next problem on your own. Or I will put this in here as well, to nested loop to print triangle of increasing numbers. 1 to 9. You don't know that yet, but here it is. Use nested loops to produce the following output: 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll just count. There's 2 2s, 3 3s, 4 4s, 5 5s, 6 6s. So in a lot of ways, this is the same as the last one. So this would be a good place to pause. If you want to set up your own pseudocode on paper, I would suggest it. This is the practice I'm looking for before you code it. Even if you can just code this immediately, the practice of setting up the pseudocode is going to be beneficial. And then we'll jump in together. So again, it's, for an integer, I don't need the code here, so I don't need to write integer. I just want to say for row, and row starts at 1, and it goes up to 9. So for each row, we're going to print a certain number of columns. Again, the column always has a first column. So it's column equals 1 up to, and again, in the first row, we have 1 column. In the second row, we have 2 columns. Third row, 3 columns. Fourth row, 4 columns. So again, it goes up to the row, just like the last problem. And then what's different here is what's different is the 9. And then what are we printing? Well, in the first row, we're printing 1. In the second row, we're printing 2s. In the third row, we're printing 3s. So, if you look at the row, this is row 1, row 2, row 3, row 4. What you're printing in each row are however many that you need of that row. So, what we're printing here inside this loop is the row. And then again, I need another print line outside this loop to get me to the next line. So there's my pseudocode. Again, it's good practice if you've just copied that down, then pause, jump over to Eclipse and type it in, or type it in with me, I'm not sure. You definitely want to do both on paper in Eclipse. It gives you the practice. So we'll just come right below here. I'll tab in. Notice I can always check this brace corresponds back to that brace with a little box around it, which ends main. So this guy needs to be within main. Now, both row and column lived inside their respective loops, so there's no problem to use them again. Row goes from 1, in this case, up to 9. In other words, the computer, oh, I need to define that row over here, declare it, integer row. And again, it's because I don't have integer over here. I have to transition from pseudocode to my implementation where I'm using actual syntax. I have to put the syntax in. Row less than or equal to 9, increase the rows by 1. Get out of that parenthesis, open the brace, hit return. Second loop for integer column starts at 1 and goes up to and including the row itself. And then we're increasing the column by 1. And again, open brace, hit return. And then I'm having just a print statement, not a print line. What we're printing is the row. There's my inner loop. Outside of that loop, I want a print statement. Or a print line statement, excuse me. Okay. Notice when you do the pseudocode, when you do it well, we won't have a lot of logic errors. We might have some syntactical errors. I forgot a semicolon or something, but the logic should be pretty sound. And if there's an issue, usually it helps to go back to the paper and figure out what the issue is. Again, these are pretty short little problems, so it's hard to see. Oh, so that we notice here, I notice here that these ones are kind of running into that one. So I might just, after I finish this first set of code, put another print line statement in outside that loop. This is just preference to help it look a little better. So there's a space between the two problems. And then as we move on to the third problem, we'll set that up again. Maybe I should be using methods to do this. So let's do that. Let's get outside of main. So here's main starting, main's ending there. So outside of main, I'm going to define a method called tower of ones. So we're going to go public static void, call it lowercase tower, uppercase of, and then 1. Tower of ones. How about that? And we'll put open and close parenthesis, and then we'll open the method and hit return, and that closes it off. So tower of ones is going to be that first method. So I'm going to steal all of that code. So everything above this print line statement up to the declaration of main, I'm cutting and pasting in to tower of ones. Now, when you cut and paste, you may have issues with the braces. Things don't come out quite right. So let's just make sure it runs right. I don't have any syntax errors, but you might have to correct them. It might even make more sense to just redo that. Notice it didn't do anything. It didn't print my tower of ones. That went away. So the problem is I didn't call that function from main. To call it, I have to invoke it here, tower of ones. So I have the function call, then I have a print statement, and then I have my second loop. And now they print it. So now we're going to do the same thing with the second function. So the second function is from this print line up to the for loop, up to that comment with the 2. So we'll call this one tower of increasing numbers. Public static void. How about increasing tower of numbers? Or better yet, tower of increasing numbers. You know, that's an awfully long function name. Maybe we just leave the increasing out. Tower of numbers. It's going to be clear from the output what it does. So I cut that. Did I cut that stuff out yet? No. So I'm going to cut from, gotta be careful here. There's the closure of main. I want to leave that alone. There's an empty print statement. I want to leave that alone. It's really from here up to there. Indent, paste, run. So now, again, it's not going to print that second tower because I didn't call the function. So I'll go back into main, tower of numbers, right in here. Tower, capital of, capital N, call the function. So now I have a function call followed by a print line statement, a function call followed by another print line statement. The functions themselves are at the same level as main. So look at the indentation. That function starts there, ends there. This function starts here, ends here. The indentation level of all the functions is the same. They all have their own stack of code so that they're not, these are not inside of main. You'll get an error or some logic issues. Okay, so now we'll run it. Open up my console. There they are. Both towers are there. Perfect. Ideally, I would just stop this video because I feel like it's gone on long enough. So let's stop it and I'll come back and do 2 more. Maybe in the same code, but I just want to have it broken up as 2 separate videos. I'm debating that. Hang on.